So here with this lesson is going to be on something known as function notation. It's actually going to be taught as a 2-day lesson in class, but I'm going to run it as one explanation right now. So what you're going to see is when I get to one part, I'm actually going to tell you to stop it, complete the homework, and then if you want, you can come back and complete the second day whenever you have a chance. But I'm just going to make it all one video instead of splitting it up into two. So here we are, we're going to start with the warm-up. I'd like you to pause the video, try the warm-up on your own, and then come back and I'll go through the explanation of the warm-up with you. So go ahead and pause it now and try it on your own. So now that you've tried the warm-up on your own, let's go over the answers. We're going to have to remember back a little bit. We're going to have to remember back to our unit on linear equations where we're working with slope. And we have to remember this formula, y equals mx plus b. We became very, very good at this formula. And if you remember, b was my y-intercept, and m stood for my slope. So in the first problem, all it wanted you to do was write an equation with a slope of y and a y-intercept of 4. In order to write an equation, we must always know what m and b represent. In this problem, the m is the 7, my slope, and my y-intercept is -4. So my final equation is y equals 7x plus -4. I took the m out, I took the b out, and I put in the 7 and -4. Problem 2 is going to do the same thing, but we have to do a little bit of extra work in this case. This time they don't give me the slope and the y-intercept, so I actually have to find it. In order to find slope, remember our formula is y minus y over x minus x. So I'm going to do 8 minus 2 over 6 minus 0. Change subtraction to plus the opposite. 8 plus -2 is 6 over 6 on the bottom, because 6 plus 0 is 6. 6 divided by 6 gives me a slope of 1. So my y-intercept is 1. My b value in this case, it was actually very nice. They gave it to me. It's the 0, 2. Any any ordered pair that has a 0 as the x value is actually your y-intercept value. So as long as you can recognize that, you then don't have to go through the work of finding b. So again, writing the equation, y equals 1x plus 2 for the second problem. We're going to continue to work with this writing of equations as we continue to move through this lesson. Again, this is something we've done previously. Hopefully you remember how to do it, and that as we continue to work with it, hopefully it'll start coming back to you. So here today we're going to look at function notation. Notation, the word notation just means to write something. So all we're doing is we're looking at different ways to write things. Everything we talk about today and tomorrow with this one lesson all go together. We know how to solve everything we're doing today and tomorrow. The trick is I'm writing it a little differently. So can you understand how I'm writing it and what I'm asking for? And then can you solve it the way you're used to? So here's some function notation. Basically what happens with function notation is we have, and we're used to, the y equals mx plus b. What happens with function notation is the y goes away and instead we put this f of x in instead. And the f of x is represented to mean a function of x. Okay? Basically an equation that is happening because of whatever x is. So f of x and y are really the only things I'm changing on you. Okay? So instead of y, I'm writing f of x. And when I give you one of these problems, if you like it in the y equals format, then rewrite it that way so you know what I'm talking about. For instance, let's look at this first problem over here. Remember that f of x is y. So I'm going to take the problem and rewrite it as y equals negative 3x plus 8, and then find y when x is 5. I'm sorry, I know my handwriting is very bad on this thing. But find y when x equals 5. So basically all I'm going to do is everywhere I see an x, I'm going to plug in 5. Well, negative 3 times 5 is negative 15. Negative 15 plus 8 is negative 7. So y is negative 7. So now I got to change it back. So f of x is negative 7. So that's all that's happening. We know how to solve this problem. We're very good at solving these problems. The only thing that's changing is instead of the y, I'm writing f of x. And the reason is f of x is usually used in a more real-world situations. If you go working in factories or engineering or manufacturing or any type of job related to those topics, you're going to be using functions more. The y equals, that's your typical mathematical notation. Okay? If you're going to be a mathematician or an accountant or some job that is very, very heavily related to mathematics, you'll see more of the y equals. But any sort of manufacturing plant or manufacturing job, engineering, as well as a lot of other jobs, electricians, plumbers, those sort of things, they're going to use more of the f of x. Okay. So let's look down at problem 2. Problem 2 is just like the first one. And if you like, we can change it to y again. So y equals negative 3x plus 8 again. This time I want to find x when y is negative 22. I change the f of x to y. So negative 22, take the y out, plug negative 22 in, equals negative 3x plus 8. We're going to solve an equation here. Move the piece without the variable to the other side first by adding the opposite. So I'm going to add negative 8 to each side. That's going to give me negative 30 equaling negative 3x. Multiply or divide by the piece with the x by doing the opposite operation and not changing the sign. Negative 30 divided by negative 3 is positive 10. Two negatives give me positive 10. So x equals 10. And it's going to stay x equals 10. Only y values change. So here's 2 more. I'd like you to try them on your own. Change the f of x's into y's. Solve the problem like you're used to, and then change the y's back into f of x's if you need to. Always remember to make sure you change any sort of subtraction to plus the opposite, so plus negative 8 in both those problems first. Go ahead, try it on your own, pause the video, and then come back when you're finished, and we'll go through it together. So now that you've done them on your own, let's work on them together. I'm going to change my f of x into y. So y equals 10x plus negative 8. Everywhere I see x, I'm going to put 3. So y equals 10 times 3 plus negative 8. Y equals 30 plus negative 8. So y equals 22. Rewriting that to be f of x equaling 22. Second problem, again, same sort of thing. I'm going to change it to y equals f of, scratch that. I'm going to change it to y equals 10x plus negative 8. And then find x when y equals negative 18. Everywhere I see y, I'm going to plug in negative 18. So negative 18 equals 10x plus negative 8. Add 8 to each side. Negative 10 equals 10x. Divide by 10. Divide by 10. Negative 10 divided by 10, giving me x equaling negative 1. Make sure you watch your signs and you keep track of them. It should be a -1. So negative, there we go. Now I got my negative more the way I like it. So here I have some practice problems for you to try. I want you to go ahead and try them on your own. And then what I'm going to do is I'm going to go through and go down the answers and give a brief explanation as we go down through them. I'm not necessarily going to write everything out. You'll notice, though, as you look over these problems, that the f of x has changed into p of x and h of x and f of x and m of x and q of x. And that's the same thing as f of x. These all are represented by y values. Just like how when we were solving the equation, sometimes we would use x, sometimes we would use z, sometimes we would use t. We can just kind of pick whatever letters we want. So go ahead, pause, try these on your own, and then I'll go over the answers with you. So now that you've solved them on your own, looking here at the first one, whoop. So this says everywhere I see x, plug in -2. So when I plug -2 into this problem, I get -24 plus 1 is going to give me an answer of y equaling -23. So f of x equals -23. Remember to change it back to the f of x. Second problem, same sort of thing. This time though, I'm going to be plugging 3 in for the x. That gives me -24. -24 plus -2 is -26. So f of x equals -26. Try not to let the fractions get you too worked up as we go through the next one. You just want to keep nice and consistent and try your best. Everywhere I see x, I'm going to plug in 3. I'm going to keep working with it as a fraction. I'm actually going to have to do a little bit of work on this one. So this is going to be 3 over 4 times 3 over 1. That's going to give me 9 over 4 plus -24 over 4. I changed the -6 into -24 over 4 by making a common denominator. So what's going to happen is now when I add these, that's going to give me -15 over 4. And when I turn that into a mixed number, that's going to give me -3 3/4 will be my final answer for problem 3. For problem 4, I'm actually going to come write the answer over here so I have a little more room. This one says when f of x is 3. So when y is 3, what is x going to be? And when y is 3, x is going to end up becoming -1. In number 5, when m of x is -2, x is going to end up becoming -1/3. Or 0.333 repeating. In number 6, when I plug in, I'm going to plug in -4 for y. So then I'm going to add 32 to each side. And that will give me 28. And that's going to give me 28 divided by 8. When I divide that by 2, that's going to become 14 over 4, which will become 7/2, which will become 3 1/2, or 3.5 if you happen to do it on the calculator. I don't have my calculator with me today, so I'm trying to do it all by mental math or writing it out. So if you have a calculator, by all means, feel free to use that. So that's the end of today's lesson. Okay, hopefully you have the worksheet that goes along with it, and you're going to do problems 1 through 5, all of them. They're just like the examples we did in class. Remember that if the f of x is throwing you off, change it into a y. That's usually one of the first things I do when I see a problem that has an f of x in it. I just flip it over and make it a y, and then work on the problem the way I'm used to. Go ahead, try the homework, and then from there we're going to move into the next day's lesson. So now you're back after you've tried the homework, so obviously the warm-up's going to kind of be reflected on that homework as well. So go ahead, try the warm-up, pause it, and when you're finished with the warm-up, click play again, and I'll go over the instructions with you and we'll go from there. So in this example, I want to find f of x or y when x is negative 8. So everywhere I see x in the problem, I'm going to plug in negative 8. So y equals 7 times negative 8 plus 4. Seven times negative 8 is negative 56. Negative 56 plus 4 is negative 52. So f of x equals negative 52. Remember that the y has to change back to the f of x. Next problem, find f of x when x equals 3. So this time I'm going to plug 3 into the problem. 7 times 3 plus 4 needs to equal y. 21 plus 4 needs to equal y. So 25 equals f of x, or f of x equals 25. Last problem on the warm-up. Here I'm telling you that the f of x is 67. So 67 equals 7x plus 4. Subtract 4 from each side. And you get 63 equaling 7x. Divide by 7. Divide by 7. And we get x equaling 9 for the answer to that one. So 9 for number 3, 25 for number 2, and negative 52 for the first one. So what we're looking at today is yesterday we basically just evaluated functions. If I give you an x value, can you tell me what the y value or the f of x would be? If I give you f of x, can you go the opposite direction and tell me what the x value would be? Here we're going to look at graphing. And again, I would strongly encourage you to just take the f of x and make it y. So y equals 3 over 4 x plus 1. We need to go back to that equation, y equals mx plus b, where b is my y-intercept, and m is my slope. So what I want to pull out of my equation here is I want to pull out my slope and my y-intercept. My slope, or m, is always the number in front of the x, so 3/4. And the b value is always going to be 0, and then the number that does not have the x with it, so in this case 0, 1. And now I want to go ahead and graph this. I'm going to pick a different color, hopefully one that'll show up well on the graph over here. You're always going to start with your b first. So b is 0, 1. So about right there on the graph. I'm going to kind of over-exaggerate a little bit so that hopefully we can all see it. Now my slope is my directions. The 3 on the top tells me to go up 3 boxes. 1, 2, 3. The 4, because the 4 is positive, it's telling me to go right 4 boxes. 1, 2, 3, 4 to right there. And put a dot. Now we're going to follow the directions again. Up 3, over 4. Put a dot. Connect the dots, draw a line. And there you go, you have it graphed out. And we've done this graphing before with the slope and the y-intercept and all of that. So it was just a matter of taking that f of x and changing it into a y. That was the only thing we've done different than what we've previously done this year. Here's another graphing one. I'd like you to try it on your own, then come back and I'll walk you through the explanation of graphing it. So here, again, I'm going to make the f of x y equals, so y equals negative 1/2 x plus negative 2. Change your subtraction to plus the opposite. My slope is going to be negative 1/2, and my y-intercept is going to be 0, negative 2. So I'm going to go ahead and graph it. Always start with your y-intercept first, and your y-intercept should always be on the y-axis or the vertical axis first. This time I have a slope of negative 1/2. The negative 1 tells me to come down one box, and the 2 is telling me to come right 2, because the 2 is positive. So down 1, right 2. Down 1, right 2. Down 1, right 2. And we could keep this pattern going on forever. Okay? Usually 3 dots on a graph is what we're looking for. Sometimes it's a little harder to get 3 dots on a graph, and that's fine. But typically 3 dots gives you a pretty nice idea of what your line's going to look like. Now we're going to write the linear function. You know what, guys? We actually did this already before too. Okay? When we wrote linear functions before, I actually hid some of these on the test for you, and you did just fine on them. So this, nothing new, piece of cake, we got this. What I'm basically doing here is I'm hiding your ordered pairs from you. So as you look at the first problem, your ordered pair here is 0, 9, and your second ordered pair is 3, negative 6. In order to write an equation, we need to find m and we need to find b. In this case, we know b. b is 9. We know it's 9 because it was the one with the 0. If you get lucky enough to have the one with the 0, please take notice of it and save yourself some time. My m, on the other hand, I have to find my slope. So I have to do y minus y over x minus x. So 9 minus negative 6 are my y values. Because the 9 went first on the top, it needs to be 0 minus 3 on the bottom. Please make sure you're changing to plus the opposite because it is going to make a difference. Because now I have 9 plus 6, which is 15, over negative 3, giving me a slope of negative 5. When I put it all together, y equals negative 5x plus 9. We actually need to change that y to f of x, so f of x equals negative 5x plus 9. And I know that's kind of squeezed in there a little bit. Same thing with the bottom one. My 2 ordered pairs are negative 4, 5, and 2, 2. I need to find my slope first, so 5 minus 2 over negative 4 minus 2 plus the opposite. That's going to give me 3 over negative 6, or negative 1/2. Now I need to find b. This time it wasn't so nice. I wasn't given b. So y equals negative 1/2 x plus b. Pick one of your ordered pairs and plug in x and y. So 2 equals negative 1/2 times 2 plus 5, plus b. We don't know what b is yet. So that is a b right there. So now we're going to go through and multiply. Negative 1/2 times 2 is negative 2 plus b. Add 2 to each side, add 2 to each side, and we get b equaling 4. So I have my slope, I have my b value. Remember that instead of y, we're going to write it as f of x. So f of x equals negative 1/2 x plus 4. 2 of these for you to try. See what you can come up with. Go ahead and pause it. Now that you've solved them on your own, we can go over them together. We're going to get 0, 1 as one ordered pair and 2, 9 as the other. Find your slope first. So 9 minus 1 over 2 minus 0. That's 8 over 2, or a slope of 4. My b value is actually given in this problem. Oh, it's not the 9 though, it's the 1. The b value is given, and it was given as 1. So f of x equals 4x plus 1. So now here in the second problem, same thing. I have the ordered pairs -6 and 16. And I also have the ordered pairs 0 and -5. So I'm going to find my slope first. So 16 minus -5 over 0 minus 6 plus positive. So that's going to give me 21 over -6. So now that I have my slope, I'm going to reduce and divide top and bottom by 3. That's going to give me 7 over -2 as my slope. My b value again very nicely was given to you. It's -5. So we don't want y anymore. This time we actually want to write it as g of x equals 7 over -2x plus -5. So now you have a worksheet to do for me for homework, but hopefully you've seen as we've gone through this lesson on function notation. First day we were just plugging in the x and the y values and kind of solving them down, and you've been doing that for years. Today we did some graphing and some writing of the linear equations, which we've worked on earlier this year in our last unit. And this time all we did was change the one variable. Instead of calling it y, we called it f of x. But that f of x really didn't change how anything played out, how the math behind it worked. So try your best on your homework tonight, and we'll go from there.